Hi there. We'll quickly recap what we learned so far. Okay. So we have learned first we have learned about the current I. I equals to Q by T. Right. Flow of charges per unit time in a particular point. Okay. So what is the unit of this current? Unit of this current is ampere. Right. 1 ampere is equals to 1 coulomb per 1 second. Right. Flow of 1 coulomb in a particular area per 1 second. Okay. What is coulomb? 1 coulomb is nothing but the charge of the unit of charge. Okay. 1 coulomb equals to 6 into 10 to the power of 18 electrons charge. Right. The charges of 6 into 10 to the power of 18 electrons will give the value of 1 coulomb. Right. 1 coulomb is equals to charge of these many electron. Okay. What is the value of 1 electron? Charge of 1 electron. 1 electron is equals to 1.6 into 10 to the power of minus 19 coulomb. It is very less. Okay. So all this charges of 6 into 10 to the power of 18 electrons will combine to form a 1 coulomb. Right. 1 coulomb. So 1 ampere equals to 1 coulomb flow of 1 coulomb of charges per 1 second in a particular area. Next, we have learned about this flow of charges, that is current. Okay. How the charges gets flow? If the charges needs to flow from here this place to this, means it needs some energy. Right. Who provides this energy? Nothing but your battery. Okay. The chemical energy stored in a battery. Right. The chemical energy stored in the battery will give the energy to the electrons here. Okay. Energy to the electrons. So that once it gains the energy, it can move from one place to another. That's force. That means work done means what? It has to move from one place to another. Right. So for that it needs some energy. The energy is given by this battery. Okay. Even if it gets energy, it has to flow. Right. That force is created by difference in potential. Difference in potential energy. Difference in potential. A potential difference has to be created. Then only it will flow from higher potential to lower potential. Right. That potential and difference. How the water, if the water has to flow, means some energy, some pressure difference has to be there. Then only it flows from higher position to lower position. Right. Likewise, if the electron has to flow, there must be a potential difference. Potential difference. Okay. Potential difference means what? Work done in bringing a unit positive charge from one place to from infinity to a particular point. Okay. From infinity to particular point, or from one particular point to another particular point. Okay. That is the potential difference. Right. So potential difference is represented by the letter V. That means what? V potential difference equals to what? Work done in bringing unit charge. Right. Charge is given by Q. Okay. Unit charge from one particular place to another particular place. What is the unit of this work done? Joules. And what is the unit of charge? Coulomb. So this V by C, this potential difference, the SI unit of potential difference is volt. Okay. So 1 volt we can represent this as 1 joule of work done in bringing 1 unit positive charge from one point to another. Right. So this is the volt. Okay. Volt is the unit of potential difference, and 1 volt is represented by 1 joule per 1 coulomb. Right. Then what we learn? We have learned some of the symbols used in the circuit diagram. Right. In the circuit diagram, we'll use this as a battery. This is positive, this is negative, and this is a single battery. Our combination of cells or batteries represented like this. Okay. Then switch closed is represented like this. Switch off. Then switch on is represented like this. And then if a wire is connected to a circuit, then it is represented like this. When a wire crosses the circuit, it is represented like this. Then ammeter is represented like this. Voltmeter is represented like this. And resistor, so resistance is represented like this. And a variable resistance is represented like this. And a rheostat is represented like this. Then what else? And one more thing, main bulb is represented like this. Okay, glowing bulb will be represented like this. Okay, fine. So these are some of the symbols used in the circuit diagram. And you know that what is the open circuit? Open circuit means there is no link is not connected. It is, the switch is closed. So there is no electricity passing over here. Okay, because the switch is closed off. Okay, once you switch is on, plug in, then there will be a flow of electrons. Then bulb will glow like this. And the current is measured by using an instrument called ammeter. This ammeter is always connected in series, right? Series. And a voltmeter should be connected across the resistor, right? Voltmeter is connected in across resistor. It has low resistance, there is the flow of current will be same here as well as here. Okay, almost same. Okay, it has high resistance, so no current will be drawn through that. Okay, so it is always connected in parallel voltmeter. And what is the purpose of connecting voltmeter? Voltmeter is a device used to measure the potential difference, because the potential difference in this side, when it gains energy here, throughout this place the potential energy will be same here. When it crosses the resistor, then only it will lose energy, and you will have less potential energy here. Okay, so here throughout this length the potential energy will be same. Here throughout this length the potential energy will be same. Only we can find out the difference in potential from this point to this point alone, because in between you will have a resistor, so that will be a potential difference between this, because here you will have a high potential energy. When it crosses the resistor, it will lose the energy in the form of heat, and you will have a low potential energy here. You can measure only the potential difference across this resistor. Okay, between the terminals, here it is high potential energy and it is low potential energy. Once it enters the battery, it gains energy, again it will get the high potential energy. Okay, clear on this? Then what else we learn? Volt. This 1 volt is equals to 1 joules per 1 coulombs. After that, Ohm's law. It is given by George Simon Ohm in 1827, and what he has given means he has find the relationship between the potential difference P and the current I. What is the connection between these two? And he found that this potential difference is directly proportional to the current I flowing through that. Okay, to remove this proportionality, he has introduced a constant called R. This is nothing but your resistance. Right? Resistance. This, what is meant by resistance? That is the resistance nothing but the property of this conductor. For example, this is a wire conducting electricity, means this is a property of this conductor which resists the flow of electrons. Okay, which resists the flow of electron. That is called resistance. This resistance is a constant for a particular wire. This is a copper wire, means then its value remains same. Okay, So this is a constant. Okay, only this voltage and I will vary. Okay, V is equals to I into R. It is a constant. R is constant for a given material. Okay, it will not change. So so this R can be, resistance can be written like this, right? R is equals to V by I. R is equals to V by I. That means resistance is the ratio of potential difference to the current flowing through that. What is the unit of this potential difference? Volt. Volt, 1 volt by 1 ampere current. Okay. Resistance equal to potential difference by current. The unit of potential difference is volt and unit of current is ampere. Unit of current is ampere, right? It is given by, the SI unit of the resistance is given by ohm, and we can represent this ohm by the symbol omega. Okay, 1 ohm is equals to 1 volt by 1 ampere. Okay, 1 ohm is equals to 1 volt resistance. 1 ohm is equals to 1 volt by 1 ampere. So we have seen up to that only, right? As 1 ohm is the potential difference across the two ends of the conductor is 1 volt, and the current flowing through it 1 ampere, means the resistance R of the conductor is given by 1 ohm. 1 ohm equals to 1 volt by 1 ampere, right?